Hello everyone, hope you all are doing very well. When you are working on enterprise data, there are several questions, whether you are new to the data engineering or you have very good experience. Topics such as why you need data warehouse or why you need data lake, or do you really need the lake house? Do you really need a data pipeline? Or if you have the data pipeline, can you combine it with your data processing system? If you have the data lake or you have the data warehouse, can you use your existing pipeline system to work on your data warehouse or your data lake? Or if you are starting something scratch, how you can start the pipeline with correct or the proper data processing which fits your data warehouse or your data lake need. What is ETL? What is ELT? Why you need ELT or why you need ETL? Why you cannot switch them together? What is the reason? Which one you choose? What constitute a modern data stack and what is changed from modern data stack to postmodern data stack? So whether you are an experienced data engineer or you are just starting your career, we know that dealing with these questions is not fun. So based on my experience, I have built the end-to-end data platforms. I decided to create this video so that I can answer most of these questions. This video is divided into the two parts. Very first part, we are focusing on various aspects related to data, such as data stack, data storage and data processing system, creating data pipeline, and the data processing system integrated with the pipeline or standalone, as well as data warehouse, data lake, lakehouse, and the data mesh. The second part of this video starts with the difference between modern and the postmodern data stack, as well as the various other analytical and the data science or the machine learning specific components. So in this video session, we are going to cover various aspects related with data, such as the data stack, modern and postmodern, and what constitute the data stack, this data storage, as well as the analytics system, the data pipeline, standalone, as well as in conjunction with data processing. Then we will look into data warehouse, data lake, and the lake house, and we will also touch up about what is the data mesh. All the things are to explain together in a way so that whether you are a newcomer or you have very good understanding about these concepts, there is something new for you to learn. Very first thing, we start with the data storage and analytical system. No matter how small the organization is or very large, the system to store data and make it available for analytical system or the systems, the process is pretty much same. You need a data capture system which collect data from one or more resources. Then you need data processing system which reads the data and process it depending on enterprise need. Finally, the processed data has to be stored. Same with raw data, something you need to store your data storage. Next, data analysis. You need to analyze the data. After that data is stored, depending on how your organization requirements are, the data analysis process could be simple or could be very complex. And finally, the data usability, how to make data usable. You need third-party application which will consume your finally processed data, or you can come up with your own application where you are going to consume the data. So whether it's a very small organization or it's super large, these 5 steps or these 5 components will always going to be there. Next, what constitute a data stack? People talk about, oh, I'm expert in modern data stack, or our data platform is actually built on postmodern data stack. So these concepts are very important to understand. So in not particular order, what you are seeing, these components, they constitute the data stack. You need a data pipeline service, means there should be a process where you can constitute your analyticals or the data processing system which works in a pipeline manner. So you need a data pipeline component, then you need a data storage service. A storage service could be a single one, like a big large data warehouse or data lake, or it could be the combination of multiple of services. You could have an object store, you could have the relational database system, cloud or non-cloud. You can also have the key value store, or you can just have the document DB such as MongoDB. So there could be a variety of data storage services you can combine in your data stack. Next, you need a data transformation service. There are several open source libraries available to start with, or if you would want to venture by yourself, you can write your own in Python, Java, Scala, Go. There are various languages which supports writing really very simple all the way to the complex data transformation applications. Finally, you also need the data visualization, you need data intelligence, and finally the modern data stack. The newer applications, they also support the machine learning and the data science capabilities. So when you have all these things together, that's where you have your data stack ready. First three are the foundation service, and last three are the additional service. You need first three to make sure you can have remaining three. In this video, we are going to focus the first three more. So very first thing with regard to data warehouse is that you are going to store the denormalized structured data. It means you have ability to process the data to a SQL-like processing framework. Whether you are using direct SQL through a third-party applications such as Power BI or anything similar to that, or you can actually use programming language where you can use library which are following the SQL-like access to the data warehouse, and you have ability to pull the data out and process it or whatever you would want to do it. So the most of the modern data warehouses are scalable. They can manage a very large amount of data without even worrying about the keys and table indexes, anything. You can store very large amount of data which is denormalized and has a accessibility through a SQL-like structure. Most of the modern data warehouse also support storing structured as well as the unstructured data both, whether you are using the PL SQL, NSI SQL, or any SQL-like framework to access the data. These modern data warehouse are also going to support you, whether through an application or directly writing a code where you are using a certain library to access the data. You are not going to store unstructured data such as images, video, audio files, large documents in the data warehouse. And that's where the next question comes, that what if you have very large amount of unstructured data such as images, documents, and audio video files and large documents, then how you can extend the capabilities of your data storage. And that's where the next thing comes in our data stack is the data lake. One of the biggest advantages of data lake is to store structured, semi-structured, and the unstructured data all together on it. It means you have images, video, files, all these things you can store as an object store along with your structured and the semi-structured data. Once data is stored at the data lake, the majority of the data lake, they give you access through programmatical methods. It means you would need to write the code either in Python, PySpark, Java, Scala, and any other supported language to access the data which is stored on your data lake. However, that method gives you higher flexibility to process the data the way you would want. One of the another advantage of data lake is that first you can store the fully unstructured data, then writing a pipeline in your favorite programming language, you can process all that data, and once you process the data and you come up with your structured information, you can write that back to the data lake. And now you have ability to add different data pipeline or the data processing method to access the structured data through a framework where you can actually use some of these modern framework which can give you access to this data through a SQL-like method. Going forward, the third thing is the lakehouse, which is the best of both worlds. An organization would like to have the data warehouse for the SQL-like access, storing structured data, as well as the ability to store the unstructured data similar to data lake. So combining data warehouse and data lake, now you have the lakehouse. Programmers can write code to process the data, build their own pipeline, do what they want to do, versus the applications which are accessing the rich structured data through a SQL-like framework. They can still use all that capabilities within the scope of lakehouse, and it's both parties are very happy. And when we try to combine all of these three together, you have data warehouse, you have data lake, and you have lakehouse. One important aspect with regard to data warehouse is that the data, structured data, which is relational, is stored is little different than when the data is stored on a relational database. In relational database, your data is stored in a raw format, versus in the data warehouse, your data is stored in the columnar data format. It means you have rows, you have columns, and you have indexes everything. However, the data is stored in a column format, which makes you accessibility for this data through a OLTP, on analytical processing, versus your relational database is designed for the transactional processing. So that's why you are using OLTP. That's a very big difference between the data warehouse is storing the relational data comparison to your relational database. And that's where we complete the general introduction to our data storage service, and that gives us the avenue for us to look into the data pipeline service. There is a data pipeline exists whenever your data is being processed from A to B. When you are going to process the data, it means you have to read the data. So you must need a data source origin where the data is coming from. And then you are going to read it, process it. After you are going to process the data, you definitely need a destination. That's where the point A to point B. You need to read the data, you are going to process it depending on the business need, and then you are going to send that data to a destination. And that's the concept of data pipeline. And within the data pipeline, the most important aspect is the data transformation, which is in the center. To process the data, there are various methodologies are defined, such as ETL, which stands for extract, transform, load. Other is the ELT, where the extract, load, and then transform. And then the ETL, this means extract, transform, load, transform. The pipeline processing could be batch. As the data arrive, processing happen, then stop. Could be stream, means data is keep coming and you have a continuous processing in your pipeline. Or it could be the CDC. In the CDC or the change data capture, you are not actually syncing or collecting or loading all the source data. Instead, you are only checking the refresh or the newer data from the last sync. And finally, the view, where you are just scanning your data, taking a look and just bypassing it, maybe not even storing it to the sync. Now let's take a look the role of data pipeline when you have a data warehouse. Definitely you need a source data. Then after you are going to process the data. Reason you are processing because the data which is coming out from the source may not be structured. It's raw data. It means you have to transform the data in a way so that it can be stored in the data warehouse in a structured way. And that's the reason you are actually processing the data first, and then you are storing the data so that your data is made available for the further downstream processing. It is very much possible that the data warehouse is using transformation both way. It means first it's reading the data, processing it, transforming it so it can be stored for the structured data, then you are also transforming the stored data on the data warehouse for the second level of processing so that your data is available for the other analytical machine learning and other downstream applications. So readiness, reason why I'm saying is that it means the transformation is not happening in one instance to make your data available for your downstream application. You are doing it two-step processing. That is in most cases. Next, we can look into the data pipeline with context to data lake. Here, as you can see, that the raw data which is coming out from the source is actually directly dumped to the data lake first, because the nature of data lake is a non-structured or the unstructured data or the document data or the object data first sits on. It means you take your raw data, you store in the data lake first, then you actually transform the data. In the second step, you are collecting the data stored in the data lake, processing it, and then you are writing back to the data lake in the same data lake. Mostly it's the same data lake where you are writing the data, but now at this point your data is structured because you have processed it, and once your data is structured, and that's where you can connect it to the downstream analytical application. So the role of data transformation with respect to data warehouse and the data lake is very different, and that is very important for you to understand. And so the role of data processing in the data warehouse pipeline as well as the data lake pipeline is different, as you have just learned. So we have completed data storage as well as the data pipeline services. So next step for us to understand the data transformation service, and that's where we are going to learn little deeper the role of ETL and the ELT. So let's take a look at the ETL first. So the ETL stands for extract, transform, and load. And you can guarantee that the extract part is always going to read the raw data. And any data which is not transformed is raw for the pipeline. So first raw data when you are collecting from the data sources, and second raw data when your data is not transformed enough so that it can be used by the downstream analytical or the intelligence application. So extract is reading raw data. Once data is read, then you need to transform it. So transform is really processing your data. Transforming can have various steps, starting from cleaning the data, rearranging the data properly, validating the data for its correctness, then checking outliers, ambiguity, imputation of your data, making sure data is ready. That's a very first level of transformation when you have raw data. Once in the second level of transformation, when you are processing the data, make it ready for analytical system, then you are actually enhancing the data quality. You are filtering, aggregating, you are doing all kinds of data manipulation processes within the data transformation. And finally, when your data is processed, then you are going to write. So load step is always going to writing or the storing your data to your target storage system. Could be the same from you have read the extract, or could be the different. The second one is ELT, same concept. The only thing is different here. The only different thing is that the order has been changed. Extract, then load and transform. And these two, ELT and ETL, we will learn through this example. And to make this example simple, let's assume that we have CSV, some data, could be multiple files related to a transaction or multiple transaction, and we want to store the data into a data warehouse. If we are using the ETL process, we will first read the data, CSV, whatever sources we needed, one or many, we collect all those data, then we will process it. What we are trying to do is that we are going to process the data, could be merging the data, could be various capabilities we are adding in our transform step. When we say transforming, we are processing, it means we need compute, we need runtime. Somebody has to provide the runtime environment so that you can complete the processing, and once processing is done, then you are going to store the data. In this example, when we were transforming the raw data so that we could store process data to the data warehouse, the runtime environment has to be made available through the data pipeline or any other mechanism, because the data is going to be moved from this location to processing location and finally is going to store there. That's where your processing, and once processing is completed, then you are going to save the transform data to the data warehouse, and that's the role of load in this ETL. In the next step, when we would want to apply the ELT or the extract, load and transform method to process the data coming out from the various CSV files similar to we have used in ETL, your extract step is not going to change. So after you have extracted, means you have read the source data, you are going to store an storage such as AWS Redshift, which is Amazon warehouse application. So you are storing the raw data in CSV format, then you are also processing the data. So the compute or the processing runtime you need in order to process the data is provided by the Redshift to you. So in this way, you are going to process the data which you are reading from the AWS Redshift, and after processing is complete, you are writing it back. So understanding ETL and ELT, extract is the same. The transform, you have to have a processing capabilities or a runtime to complete the transformation, and you might be using the SQL processing, or you are actually completing the processing by writing your own custom code. And the choice to use either ETL or ELT is depend upon what kind of data integration project you are running and the environment you have. Because last example we have looked into that using the ELT was very good when we decide to choose the AWS Redshift. We can summarize that the ETL process is more useful and more applicable when you are going to perform the complex data transformation. Means the time to spend in processing is significantly larger, and that's where the ETL is. However, the role of ETL is more important when you are going to process a very large data set that requires the high performance computing power. It means you need a significant larger capacity of compute when you are going to use the ELT. For the sake of completeness, we can take a look at a very popular data warehouse solution through Snowflake. You have various types of source data which you can store in Snowflake, and Snowflake environment actually gives you capability for data engineering, data lake, data warehouse. You can apply various data science methods on top of your data when your data is stored in Snowflake. Snowflake also gives you ability to create the data apps on top of your data, while your data apps are actually using the Snowflake compute, and you also have the capability to exchange the data in between or the third-party applications connected with your Snowflake data warehouse instance. And the data which is stored on Snowflake can be consumed by various consumers as explained here. When you are going to create your Snowflake instance, you can choose which cloud, such as Google Cloud, AWS or Azure, wherever you would want to run your Snowflake instance. If you would want to perform the data transformation, you can choose the methods which are available in the data warehouse, such as we have seen in Snowflake. However, you can use third-party tools such as dbt, which is data build tool, and you can create the full end-to-end orchestration methods to read the data, process it, and write back to the Snowflake as explained in this image. dbt is the tool which can process your data, and you can enhance the capabilities of the dbt by adding it with a pipeline processor such as Apache Airflow. So combining Apache Airflow with the dbt, and while running this whole thing on Snowflake, you can actually create your own data transformation pipeline in the data warehouse. There are several other pipeline systems also available open source which you can use. So in this video, we have completed 3 concepts related with our modern data stack: data pipeline, data storage, and the data transformation service. The remaining three, data visualization, data intelligence, as well as the machine learning and data science capabilities in modern data stack, and the definition of modern as well as the postmodern data stack, what constitute your data stack to be modern or the postmodern, that's all we are going to learn in the next video. Before you go, one last topic I just wanted to cover, that is data mesh. Sometimes organizations, they are large enough that the different units or the different groups, they want to have their own data warehouse or their own data lake. It is very much possible. It means within a single organization, multiple data warehouses and the data lake exist. So the data mesh is a decentralized data storage architecture which supports both data warehouse as well as the data lake within a single organization, managed or governed by two separate business units. So in this example, this business unit has the data warehouse, this business unit has the data lake, and this business unit has the lake house, for example. However, this business unit would want to access the data stored in this data lake or this lake house. Without the movement of data, they can access the data from here to here, and same way this group can access these two and this group can access these two. And if you have a decentralized architecture where the data can be accessed by the different business unit without the movement of data, then you have a perfect data mesh. So the part first of this video is completed. Thank you so much for your time, and I'm looking forward to seeing you in the next video to learn more about modern as well as the postmodern data stack and the various other analytical and the data science capabilities to be added in your data engineering platform. Thank you so much for your time, and I'm looking forward to seeing you in my next video. Until then, thank you so much.